Okay, 1.11, logical reasoning. Okay, logical reasoning. Okay, an argument is a service or sorry, is a sequence of propositions called hypotheses followed by a final proposition called a conclusion. So hypotheses, okay, and conclusion. Hypotheses is the plural of hypothesis. Okay, so you could have more than one hypothesis, you could only have one conclusion though. Okay, an argument is said to be valid if for all of the assignment of variables then none of the scenarios, okay, an argument is valid if for all of the assignment of variables, then none of the scenarios produce all hypotheses to be true, okay, or if for all scenarios where the hypotheses are true, then the conclusion is true. Okay, so this is if I have multiple hypotheses. Okay. Okay, so okay, we've kind of already seen what happens when we have a conditional statement. Okay. If we go back to conditional statement, okay, if we have P goes to Q, okay, and we have P and Q, oops, P and Q, sorry. If we have a truth table, T, T, F, F, and then T, F, T, F, okay, we said that if it's true, then it goes to true, then this is true. If the hypothesis is false, okay, it's still valid. It's still a valid statement, regardless of whether the conclusion is false. The only one that's going to produce a false statement here, or an invalid argument, is if true goes to false. Okay, this is the only one that doesn't work. Okay, and we're saying, look, if we have a true hypothesis but a false conclusion, it's false. Otherwise, it's true. Okay, but we're generalizing for multiple hypotheses. Okay. Okay, we're saying, okay, that if we have hypothesis 1, hypothesis 2, okay, all the way to hypothesis n, implies the conclusion. If this is a tautology, which means that it's always true, okay, then the argument is valid. Okay. Okay. If H1, H2, ... to Hn is false, then the argument is also valid. However, if the conclusion, if H1, H2, ... to Hn okay, is true, but C is false, then the argument is invalid. Okay, to make an argument invalid, we need a scenario where all hypotheses are true, but the conclusion is false. That is, T and T and T and T, all the hypotheses are true, but that implies a false conclusion. Okay, or T implies F, okay, which is false. Okay, example 1. Okay, show that the argument is valid or invalid. Show that the argument is valid or invalid. Okay. Okay, so, okay, what's the argument? Well, P goes to Q and P and Q. Okay, therefore Q. Okay, if I have two hypotheses, P goes to Q, P and Q, therefore Q. Okay. Okay, we can think of this as P goes to Q and P and Q. Okay, implies Q. Okay, so let's draw a truth table. P, Q, P goes to Q, P and Q. Okay, and then I'll put another Q over here actually. Okay, because I want to combine these eventually and have it go to Q. Okay. Okay, so we've got P. Well, maybe I won't. Well, we'll see. We'll just leave it there for you. So P goes to Q, P and Q, and then we can think of it. Let's combine them. P goes to Q and P and Q. Okay, that makes more sense. So P is going to be true, true, false, false. This is TF, TF. Okay, P goes to Q. Okay, what is that? P goes to Q. Okay, is true goes to true. That's true. The only one that fails is this guy. This is F, true, true. Okay, P and Q. Well, that's true, false, false, false. Now I'm going to put these two together. That's true. False and false is false. True and false is false. And true and false is false. So what's the only one that's true? Okay. When, okay, and does this thing, okay, let's look at Q. Does this thing imply Q? Okay, where is it valid? I'm going to put Q over here. True. Okay, and then false. And then true. And then false. Okay, now notice that if I look at these two columns, this column here and this column here, that the only place that it's true, it's also true, right here. The other places it's false, but we don't really care. We don't really care about the false ones. We don't care about the false ones because they're all valid. It doesn't matter what the conclusion is. Okay, this is valid. These are all valid. Okay, And even true to true is valid. So for every scenario here, it's a valid statement. Therefore, therefore the argument is valid. Okay, why is it valid? Because we didn't end up with any TFs. A TF is death. Okay, two valid arguments. A T with an F, not good. Okay. Let's try another example. Okay, example 2. Okay, check the validity of the argument. Okay, check the validity of the argument. Okay, not P. P goes to Q, therefore not Q. Right? So not P and P goes to Q implies not Q. Is that valid or invalid? Okay, well, let's see. Truth table. P, not P. Okay, P goes to Q, not P and P goes to Q, and then not Q. So P is true, false, false. Okay, I guess I need Q there as well. Let me put in the Q as well. Just so we know that what we're dealing with here. That's true, false, false. Okay, not P is false, false, true, true. P goes to Q is true, false, true, true. Combining these two, okay, the not P and the P goes to Q, that's going to be a false. That's going to be a false. That's going to be a true. And that's going to be a true. I believe. Let me think about this for a second. P goes to Q is true, false. Yes, yes, I like that. True, false, true, true. Okay, and then false, false, true, true. So that's a true and that's a true. I think it's the same. Okay. Okay, so does that imply not Q? Well, what's not Q? Not Q is false, true, false, true. Okay, now I have a bad one. This is invalid. It's invalid because we say, oh, well, does true imply false? No, it's invalid. Okay, that's the bad one. Okay, thank you, Logan. So the statement is invalid. Okay, when is the statement invalid? The statement is invalid when, oops. The statement is invalid when I have false, P is false and Q is true. Okay, the hypotheses, okay, are both true. Okay, the hypothesis is what? This guy is true, and this guy is true, but my conclusion is false. So the hypothesis, not P, is true. P goes to Q is true. So my hypotheses are both true. However, my conclusion is false. So it's invalid. Okay, example 3. Okay, check the validity of the argument okay, R and S, not R or not S, okay, therefore, not R implies S. Okay. Okay, let's think about the validity of this. R and S combined with not R and or not S. Okay, and that they're saying that that implies, okay, not R or goes to S. Okay. Now, can anybody see right off the bat why this is invalid? It is invalid. I'm sorry. It is valid. It is valid. Sorry, it is valid, not invalid. Okay, it is valid. And there is a reason for that. Okay. So the reason is that the hypotheses together are always false. This thing here is always false. Which means that it's valid. I can never get a true goes to false here. Okay, it's always false. Why would that be always false? Well, it's always false because we can use De Morgan's law to pull out that negation. Okay, so this is always false because we can pull out that negation. And what does this mean? This means that if I take R and S and I combine it with its opposite, so if R and S is true, then its opposite is false. But if R and S is false, then its opposite is true. Does that make sense? So no matter what I get for R and S, I'll always be combining it with its opposite. And the and statement shows that that's always false. The hypotheses are always false from De Morgan's laws. So it doesn't matter what the conclusion is, it's always a valid statement. Okay.